So how do thousands of containers inside a single Kubernetes cluster actually talk to each other? And more importantly, why does the way they do it matter so much? It's one of the most critical choices you'll make for your cluster, and it affects everything from raw speed to rock-solid security. Okay, let's dive in and really unpack how this all works.
So here's what we're going to cover. First, we'll tackle the basic puzzle of Kubernetes networking itself. Then, we'll look at the universal standard that makes it all possible. After that, we'll meet the three big contenders in this space. We'll put their performance under the microscope to see what the data says. And finally, we'll give you a simple framework for picking the right one for your needs.
All right, so at its heart, Kubernetes networking is really about solving a puzzle that, well, it kind of created for itself. The big question is, how do you get all of these moving parts, pods, the server nodes they live on, and the services that connect to them, how do you get them all talking to each other reliably across a huge, constantly changing cluster?
To make this all work, Kubernetes lays down a few really powerful ground rules. First, every single pod has to be able to talk to every other pod directly. And, this is key, without any complex network address translation or NAT. That's the stuff your home router does to hide all your devices behind one IP address. Here, there's no hiding. Same goes for nodes talking to pods. And a pod's IP address? It has to be its one true IP, seen the same way by everyone. Now, these rules create this beautiful, flat network, but they also create a huge engineering challenge that Kubernetes, by itself, doesn't actually solve. Instead, it uses this brilliant plugin model.
And just getting everything connected is kind of the easy part. I mean, just look at this diagram. This is a whole framework that researchers had to build just to test the performance of these networks. You've got deployment profiles, an auto deployer, a whole system just to manage the tests, logging, visualization. The complexity here is a massive clue that the network you choose isn't some trivial thing. It's a deeply engineered system.
So, if Kubernetes doesn't handle the networking itself, how does it manage all this complexity without locking you into one specific technology? Well, the answer is this amazing concept that works kind of like a universal adapter. And that answer is the Container Network Interface, or CNI. The best way to think about it is as a universal adapter for networking. CNI is just a standard, a spec that basically says, hey, if you want to plug a network into a container, here's how you do it. This lets Kubernetes just hand off all the messy details, like assigning IPs, setting up routes, to these specialized plugins. It's just like having a standard USB port. You don't care about the brand of the keyboard, you just know it'll plug in and work.
And the way it works, it's actually pretty elegant and simple. When a new pod spins up, the main Kubernetes agent on the node calls the CNI plugin with an add command. The plugin does its magic, sets up the network, gives it an IP. Later on, Kubernetes might ask it to check if everything's still okay. And then, when the pod gets deleted, a del command tells the plugin to clean everything up, release the IP, tear down the interfaces. It's a simple, predictable lifecycle that keeps things incredibly tidy.
Okay, so now that we get the CNI standard, let's meet the three heavyweights, the big plugins that pretty much dominate the landscape today: Flannel, Calico, and Cilium. And as you'll see, each one is built for a different kind of person with a different set of priorities.
So first up, we have Flannel. Look, if you're a hobbyist, if you're running a small startup, or you just need a network that is dead simple to set up and just plain works, Flannel is your guy. It is the definition of straightforward. And you see stuff like this all over the place online. This Reddit comment just nails it. The nice thing with Flannel is it is damn simple, robust, and its performances are rather good. And that's the whole appeal. Simplicity. But here's the trade-off. That simplicity means it's missing some of the fancy features, like network policies for really specific security rules.
Next up is Calico. Now, this is the CNI for the big leagues, for the enterprise, for regulated industries, or for anyone whose #1 top priority is security. If you're putting on your Chief Information Security Officer hat, you're thinking about Calico.
Calico's superpower is its incredibly rich network policy engine. It lets you slice and dice your network security with this concept called micro-segmentation. But what's cool is it's also built for speed. Instead of wrapping up traffic in an extra layer, it uses BGP. That's the same routing protocol that runs the actual internet to create these super efficient direct paths between all your pods.
And finally, we've got Cilium. This is the CNI for the speed demons. We're talking high-frequency traders, online gaming companies, any application where raw performance and every single microsecond of latency is absolutely non-negotiable.
Cilium's secret weapon is this revolutionary technology called eBPF. So what's so special about it? Well, eBPF lets Cilium run its networking and security logic directly inside the Linux kernel. That is the absolute fastest place you can possibly be. And because it's in the kernel, it unlocks these incredible powers, like being able to understand application traffic, like HTTP calls, providing insane visibility with its tool Hubble, and even replacing core Kubernetes components to go even faster.
So, okay, we've got these different approaches, right? Simple overlays, direct routing, this wild kernel-level eBPF stuff. But the real question is, do these architectural differences actually translate to measurable gaps in performance? Let's look at the number. So, does it really matter? The data says, oh yeah, absolutely. Take a look at these charts on the left. They're all about raw speed. The top one is throughput. Higher is better. See those green and red bars? That's direct routing. They're hitting close to line speed. Now look down at the purple and light blue bars. Those are the overlay networks. They are way slower. The bottom chart is latency, where lower is better. Same story. Direct routing is way faster. And then over on the right, you can see the huge performance price you pay for security. Adding encryption can make latency just explode. Yeah, the difference is night and day.
Let's put some really hard numbers on that. This choice is not just academic. In one performance study, researchers found that an overlay network like WeaveNet can tack on over 50% more latency for small data packets. For a real-time app, that 52% overhead is literally the difference between success and failure. Even Flannel Simpler mode adds almost 40% latency. It just goes to show how much performance you can be leaving on the table if you make the wrong choice.
All right, we've gone through the concepts, we've met the contenders, we've looked at the hard data. Now let's just pull it all together into a really clear, actionable way for you to make a decision.
So, how do you pick? Honestly, it boils down to what your single biggest priority is. If you just need something simple and reliable that just works, especially for a smaller setup, you go with Flannel, no question. If your world revolves around fine-grained security policies and proven enterprise control, then Calico is the industry standard and it's your best bet. And if you're chasing every last drop of performance, the lowest possible latency, and the deepest visibility into your apps, then Cilium and its eBPF magic is the future, and it's ready for you today.
At the end of the day, the CNI plugin you choose is the literal foundation for your entire Kubernetes cluster. Everything, the performance, the security, the stability of every app you run, it all rests on this one choice. So the final question you've got to ask yourself is this: are you building on rock or on sand?